Hey everybody, here we are in West Virginia, obviously. All right, so are you ready for joke of the day? Because it's the best part of the day. So, although the invention of the shovel was groundbreaking, and the invention of the broom truly swept the nation, it was the invention of the wheel that really got things rolling. So let's roll into adding polynomials. We now know what polynomials are and how to classify them by degree and by the number of terms. So now we're going to take a look at what it takes to add polynomials. We need to understand that when we see something like this, what it is telling us, the variables actually represent something. So when I have an x to the fourth, that represents, well, it represents 4 x's being multiplied together, but it represents a particular number. So what's happening here is it's saying I've got 3 of those, whatever that x to the fourth represents. Well, let's say it represents a red marker. So I have 3 of these red markers, and within this polynomial, I have 8 of whatever that x represents, and minus 9, just 9 individual numbers. I'm going to add to it this polynomial. So what happens here is I can combine up things that are alike, and that's what we call combining like terms. When you combine like terms, what you're going to do is you're going to say, well, you know, this x to the fourth is just like this x to the fourth right here. And then, like I said, this means I have 3 of these in a pile in front of me. This says I'm taking out 4 of them. Well, I don't have 4 to take out, so I take out 3. I go into the whole 1 of them. Notice that I said 1 of them. So that means that when I combine these two like terms and I put that 3x to the fourth together with that minus x to the fourth, when I put those together, I just went into the whole 1 of those x to the fourths. Now, you know you don't have to show a 1 as a coefficient. I definitely need that negative to show that this is a negative and not a positive, but I don't necessarily need to show the 1. Now, moving forward from there, we talked about polynomials being written in descending order. So after a 4th power would come a 3rd power, but I don't see any 3rd powers in here. So I'm going to skip over the 3rd power, and I'm going to go down to the next power, which would be 2nd power, and I see that I do have a 2nd power here, but I don't have any other 2nd powers. So it can't combine with anything, and I'm just going to carry it on down as is. Remembering that the sign in front is the sign that goes. Remember that sign in front is like a name tag. It sits on your front. You don't put your name tag in the back. It stays on the front until you leave the meeting. So the sign in front is the sign that goes. And I'm going to carry that 5x squared down. Now, in descending order, what would come after 1st power would be after 2nd power. I'm ahead of myself. After 2nd power would be 1st power. And I do see that I have a 1st power right here with that 8x, and I have another 1st power right here with that 6x. And it's saying to me, like literally the letter x, I have 8 of them sitting in this pile in front of me. I'm going to put 6 more of those x's in the pile in front of me. So if I have 8 of them in front of me, I put 6 more of them in front of me. How many of them do I have now? Absolutely, I have 14 of them. So when I take that 8x and I combine it with that 6x, that tells me I have 14 of those x's sitting in front of me. Hear those words very clearly, 14 of these x's. And then what happens last is these little not coefficients, but these constants that are in the back. This negative 9 that you see right here, so let me get a different color. Negative 9 that you see right here, and then negative 20 that you see right there. I'm going to put those together, and we know how to work with sign numbers. We know that when we take a negative 9 minus 20, we get a negative 29 out of that. Now, none of these are like terms, because like terms have the same variables, and those variables are to the same power. So none of these are alike. I can't put them together, and so I am done. So hopefully what you're seeing is the idea of being able to combine like terms means that you are going to combine the coefficients, and keep the variables. Because what you're going to do when you combine up like terms, you like that they're alike. You don't want to mess that up. You want to keep what's making them alike. What is making them alike is the variables. So I'm going to keep the variables as they are, and I'm simply going to combine up the coefficients as I see it. So if I take a look at the next one, once again, I'm taking this trinomial, 3 terms. Terms are separated by addition and subtraction. So I've got a term sitting right here. I've got a term sitting right here. And then I've got that constant that's sitting in the back, right here. So I've got a trinomial sitting there. I have a trinomial sitting here as well. So I've got a term sitting right here. I've got a term sitting right here. And I've got that constant sitting there in the back. So again, another trinomial because it has 3 terms. Notice the sign in front's the sign that goes. So when I go to combine these polynomials up, these 2 trinomials, I'm going to start with the highest power that I see, which is the x to the 3rd power. I don't see any other x to the 3rd powers. So I'm going to carry it down as it is, and I'm going to carry down a negative 4x to the 3rd. Now when I go in descending order, 2nd power would come next. I see a 2nd power right here. Again, there are no other 2nd powers, so I'm going to carry it down with its sign. This is positive, so I'm going to carry it down as a positive. In descending order, what would come next would be the 1st power. So I see that I have a 6x minus an x. So I'm going to take that 6x, I'm going to minus that x. It's like literally saying I have 6 of these x's sitting in a pile in front of me, and I'm going to take one of them out. When I take one of them out, I'm left with 5 of those x's. So I have a positive 5x left that is combining with my negative 4x to the 3rd, and also combining with my 5x squared. Now on to those constants that are in the back. And those combine, and we know how to work with our sign numbers. Positive 1 minus 12 will give me a negative 11. And there it is, because none of these are like terms, and I can only combine up terms that are like. Because it's like saying I got negative 4 of these blue markers, 5 of these green markers, and 5 of these red markers. Well, I can't take blue, green, and red markers and put them together and call them like a red, green, blue marker. It doesn't work that way. These are separate entities. So these are separate entities as well. And since I cannot combine up anything else, I have no more like terms. Like terms have the same variable. Those variables are to the same power. Then that means that I'm done. So let's take a look now at a different format for combining up like terms or adding polynomials. This is what we call horizontal format because it's all written side by side horizontally. There's also something called vertical format. Vertical format looks like this because everything is lined up vertically. Some people love vertical format, some people hate vertical format. Those who love it, they love it because everything is lined up. And I can see where my like terms are. So if I have an 8x squared plus a 2x minus a 1, that trinomial, 3 terms, being added to this trinomial, again 3 terms, what I'm going to do is I'm going to combine up the like terms. Remember, like terms have the same variables, those variables to the same power. So my 8x squared will combine with that x squared, kind of like saying I got 8 of these blue markers. I throw one more blue marker in the pile. That means I have 9 of those blue markers. In other words, 9 of those x squareds. Hear those words very clearly. 9 of those x squareds. Now going in descending order would be 1st power, and I can see, yeah, I got 2 of these x's in the pile. I'm taking out 4 of those x's, so I just went in the whole 2 of those x's. So a 2x minus a 4x will give me a negative 2x. And again, what people love about vertical format is everything is lined up. So then when I take a look at that negative 1 plus 7, we know how to work those sign numbers. Negative 1 plus 7 is going to be a positive 6. And none of these are like terms because remember, like terms have the same variables, those variables to the same power. These have different powers, so I cannot put them together. And I'm stuck, and there's my answer. So in this final example for adding polynomials, we need to remember that, again, vertical format lines everything up. There are no other 4th powers down here. So this negative 4x to the 4th won't combine with anything. I'm going to carry it down, remembering, sign in front is the sign that goes. Keep that name tag on the front. And now when I work with my 3rd powers, I have 3 of these, whatever the x to the 3rd stands for. I don't know what it represents, but I got 3 of them. And I'm taking 9 of them out of the pile. I had 3, I took 9 of them out. I just went in the whole 6 of them. So minus 6x to the 3rd. In other words, what I'm doing here is I'm combining up those coefficients. I know that 3 plus a negative 9 is a negative 6, and I'm going to retain what's making them alike. The variables is what's making them alike. So I'm going to keep that variable the way that it is. And then here, with my negative 7x squared plus a 7x squared, again, these are like terms because they have the same variables, those variables to the same power. But when I look at that, I say, okay, when I combine up a negative 7 plus a 7, it cancels out to be a 0. So I don't have any of those x squareds. I could write it this way, 0x squared, like that. But 0 times anything is 0, so essentially that's not even there. So in other words, I don't really have to show it. They just cancel each other out. Now when I look here at the x to the first power, I have negative 1x minus 5x. They are like terms because they have the same variable to the same power. I can work those coefficients. A negative 1 minus 5 is a negative 6. And I'm going to keep that x because that's what's making them alike. I'm going to retain what's making them alike. The variables is what's making them alike. And now finally in the back of this constant, there is no other constant. So I'm just going to carry it down with its name tag in the front. Sign in front's a sign that goes. So here it is. None of these are like terms because remember, let me go ahead and write this down. Like terms, because I keep saying it, so it's worth writing. Like terms have the same variables and those variables are to the same power. To the same power. Worth writing because you'll hear like terms an awful lot. And because I like an outline form, I'm sure you've noticed that would be a letter B in my outline form. There we go. And so again, here is my answer for that one. I took this 4 polynomial, 4 terms, added this 4 polynomial, and got another 4 polynomial, which is coincidental. We could have combined those, they canceled each other out, but if they didn't, this would become a 5 polynomial. So just because you add up a 4 polynomial with a 4 polynomial doesn't guarantee that it's going to be a 4 polynomial. It's coincidental there. Anyways, this is how you add polynomials. You combine up like terms. The way you recognize them is same variable and those variables to the same power. Once you recognize them, you combine the coefficients using the rules of sign numbers that you know, and you keep that variable the way that it is because that's what's making them alike. And we like that they're alike. All right, hope that helped. Have a great day.